Hi guys, this is Sachin. Welcome to Decoders. So in this video I will explain how to solve the fractional knapsack problem using the greedy approach. So first of all, let's see what is knapsack problem. We have given n objects i1, i2, i3 and so on, and with each object we have some associated profit value, that is P, and some associated weight W. Now we have a knapsack with capacity capital M. So according to knapsack problem, our objective is to maximize the profit such that total weight inside the knapsack should be less than or equal to capital M. That means we have to select those objects which gives us the maximum profit, and also the knapsack should not overflow. Now the second constraint in this is we can take objects in fractions also and can only take each item only once. Mathematically we can represent it as the maximum profit will be summation of Pi xi from I is equal to 1 to n. That is maximum profit we can get is summation of I is equal to 1 to n Pi xi, such that summation of Wi xi from I is equal to 1 to n should be less than or equal to capital M. So the addition of it should not overflow the knapsack capacity, and xi is greater than or equal to 0 and less than or equal to 1. Now that means either we can take the whole object or we may not select the object, or we can take the fraction of the object. So it should be greater than or equal to 0 or less than or equal to 1. Now consider a knapsack problem. We have 3 objects and weight associated is W1 18, W2 15, W3 10, and profit is P1 25, P2 24, P3 15, and the maximum capacity, that is the knapsack capacity given is 20. Now many people do a big mistake, that is they start finding the feasible solutions. Now suppose if you have 10 objects and the maximum capacity is 100, can you tell me how many feasible solutions will be there if you can take the objects in fractions also? I think you can't tell me. So remember that you don't need to find feasible solutions for solving fractional knapsack using greedy approach. Always remember this point. So let's see the first approach that we can have. Now since it's a greedy approach, so we should take either the maximum profit or the least weight, means we need to find the maximum profit. It should be greedy. Okay. So in first approach, let's take the object in decreasing order of their profit. So the object which has the maximum profit, consider it first and then the next objects. So that's why we are taking them in decreasing order of their profit. And second thing is, take all the objects completely until there is no overflow. That is, if the knapsack is not overflowing, then take the objects completely. And if the knapsack overflows, then take the fraction of the current object or the object for which the knapsack overflows. Now later on we will see that this is not the best approach because it doesn't give us the optimal solution. How to find the fraction and how to find whether there is an overflow or not, and if there is an overflow, what to do next. So let's take first object. The weight of first object is 18, and now if we take the complete object, then xi will be 1 and summation of I is equal to n to 1 to n, wi xi will be 18 because now there is only one object. So wi xi summation will be 18, and we can see that it's less than or equal to m, that is 20. So no overflow is there. So we will take it completely. Now let's consider consider the second object. The weight is 15. Now if we take the complete object, then xi is equal to 1 and summation wixi will be 18 plus 15, that is 33. Now this is greater than 20, that is the maximum capacity of knapsack. So there is a overflow. So what to do next is find the fraction of this object so as to fill the knapsack completely. So remaining capacity is 20 minus 18. So that comes to 2, and so the fraction of object will be 2 by 15. That's how you find the fractions. So let's solve the given knapsack problem using the first approach. Okay, so we are taking the objects in decreasing order of their profit. So the table will be same because they are already sorted in their decreasing order of profit. So first object we are taking completely because no overflow is there. Now when we are taking second object, overflow is there, so we will take 2 by 15th part of it. Okay, so the total profit we will get will be 25 plus 24 into 2 by 15, that comes to 28.2. In second approach we will consider weights. So what we will do is we will take as much number of objects so as to increase the profit. So the more number of objects will be there, the profit will be more. But later on we will see that this approach will also fail. So in this also we can take all the objects completely until there is no overflow, and if the knapsack overflows, then take the fraction of the current object. Let's try to solve the given knapsack problem using the second approach. So we have sorted the objects in increasing order of their weight. Now we have taken the third object completely and second object, and we have taken 2 by 3 part because when we are taking second object the knapsack is overflowing. That's why we have taken only the 2 by 3 part. Now the total profit comes as 15 plus 24 into 2 by 3, that is equal to 31. Now the third approach. This is the final approach and gives the optimal solution. This uses basic maths. Now if we take the per unit profit of each object, then we can say that the object which is giving maximum profit for 1 unit of weight will also give the maximum profit if taken in any fraction as compared to other objects. So if we take the unit weight of each object, and suppose object A is giving the maximum profit for unit weight, then we can say that for any fraction the object A will also give the maximum profit. So this is the best greedy approach for solving knapsack problems, and this also gives the optimal solution. So how to solve the knapsack problem using this third approach? So first we will find the per unit profit, that is P by W ratio. The first step will be find Pi by Wi. Next is we need to sort the objects according to decreasing order of their P by W ratio. Okay, and the third thing is the same, that is take all objects completely until there is no overflow, and fourth is if the knapsack overflows, then take the fraction of the current object. Now let's solve the given knapsack problem using this approach. So the data is given. Now we will find the P by W ratio. So for object 1 it's 1.39, for object 2 it's 1.6, for object 3 is 1.5. Next we will sort this data in decreasing order of P by W. So object 2 will be taken first, then third, then object 1. Okay. Now object 2 can be taken completely because knapsack is not overflowing, and object 3. So we will take half part of object 3 since knapsack is overflowing. Okay. So the total profit will be 24 plus 15 into 1 by 2. So it will become 31.5. Now we have profit using three different approaches. So by first one is 28.2, by second one is 31, by third one is 31.5. So from above results we can say that the profit obtained by using third approach is maximum. So the third approach gives the best solution, and we can't find any other better solution than this, because there is no other approach which can find the better solution. So we cannot have a solution or value greater than 31.5. So for solving the problems we just need to apply the third approach and not the first and second approach. Thank you guys for watching this video. Please like, share, subscribe and stay tuned.